Hello friends, welcome to my channel, that is Hariharan Express channel. Today I will discuss that is a 4-bit arithmetic circuit and its corresponding functional table and corresponding functional table. Okay, so this topic I will discuss today. Actually, what happens whenever you go through this arithmetic circuit, what kind of a concept are there and what kind of functions we have to design. Okay, we have to consider. Normally, what happens, the basic component of a arithmetic circuit is a parallel adder. Whenever you go through any kind of arithmetic operation, normally basic concept, whenever you go through any basic concept, that is a through some parallel adder, means parallel number of adder we have to consider. Here since it is a 4-bit arithmetic circuit, so we have to design. Here also we can write that is a design 4-bit arithmetic circuit. Then what happens, we will consider that is a parallel adder. Since 4-bit arithmetic circuit, so we have to consider that is a full adder. Okay, full parallel adder, full adder having four full adder, because here is 4-bit, so 2-bit you can 2-bit can take it, but here is since we consider 4-bit arithmetic circuit, so 4 full adder we can consider. So by controlling such kind of data inputs to the adder, what happens, different types of arithmetic operation can be considered or can be developed. Okay, and whenever you go through these arithmetic circuits, the data collected from different inputs, that is 4 inputs, that is suppose adding of any 2 operands, suppose a b, 2 operands we will consider. Since it has a 4-bit, so 4-bit of 2 data we can consider. For example, suppose a b having 2 data. Okay, then we can consider that is a data like this, a3, a2, a1, a0, like this we can consider. Similarly, b for b, b3, b2, b1, b0. So in this way, so data can consider. After that, what happens, for that is a full adder we will consider for adding. Okay, one part add from a, another part add from b. So whenever you go through 4 adder, we will consider one part a, another part b. But with the help of multiplexers, we can also use with the multiplexer. Okay, with the multiplexers, that is 4 multiplexers is required. Why it is 4 multiplexer, I will show you. That is a multiplexer why you will use, and one part is a multiplexer for that is a b part is a multiplexer, and a part is directly go to this adder. So whenever I go through adder, then what happens, very basic concept we will consider. One part is direct, a part is adder, suppose here is adder, okay, or full adder we can write it, full adder. Then another part, b part, the b part go through some multiplexer. Okay, so b part through some multiplexers data, okay, multiplexer data, and this is transferred to full adder. In this way, different data we can consider. Direct we can consider, because different category of operations we have to consider. In that case, what happens, we consider different data for adding, for directly go from a, another from b. But think that whenever you go through multiplexers, some logic also, logic connection also you can use to activate that particular multiplexer, and different values also we can find out. So logic, some logic can say 0 or 1, that concept also we can consider. Okay, and some control, the multiplexers also controlled by 2 selection variables, S0, S1, because number of bits are there, A0, that is B0, B0, B1, B2, B3 through multiplexers. Since 4 inputs given to multiplexers, then we will consider 2 selection variable. Okay, 2 selection variable we can use. Okay, that is S1, S2, S0, S1, S0. That 2 selection variable we can consider. Another is whenever we add, then some carry bit also we can find out. So carry in or carry out also we can consider. In this way, So different basic concept is required to design, that is a 4-bit arithmetic circuit. Okay. So if we go through that one, then I will show you one standard equation will consider by which they will it will evaluate different kind of mathematics operation, means arithmetic operation. The standard equation is like D is equal to A plus Y plus Cn. Okay, this equation is very standard equation for any kind of arithmetic operation. Any kind of arithmetic operation. So one part is A is fixed. A is always considered from one part for addition. Another part B, what happens? We will consider B part, sorry, Y part. Another Y is considered from B through some multiplexers. Whenever we add some data A and B or A plus Y, then some data also carry in. Okay, carry in, carry out data also we consider. So C in also we can use. For that reason, the standard equation, arithmetic equation is defined for this circuit, for arithmetic circuit, using one part is A, another part is Y, another part is Cn. Y, A part is directly go to the full adder, but Y part whenever consider, that is through B variable it will receive, and it will create a number of data, either B data, B complement data, B like this, different data. Sometimes B data not required, like this. We will see that. Then it will be defined through certain multiplexers, and after adding this Cn, then complete data we can get it. So this is the basic concept. For example, suppose D is equal to A plus B, means Cn is 0, automatically A plus B. If Cn is 1, then D is equal to A plus B plus 1. Okay, like this we can also define. Depend on that. If Cn is 0, then A plus B. Cn is 1, A plus B plus 1. This is the one kind of concept. So other also we can write it, we can, since it is arithmetic operation, we can also write A minus B. So how to define A minus B? Direct you can define. So other concept also there. That is minus B means, that is plus B complement plus 1 is minus B. Okay, that means A plus minus B. So minus B defined through B complement plus 1. In this way, different concept also we can consider. Okay. So now we will start that work to design this 4-bit arithmetic operation. Very simple way I will design. You can see how it is designed, particularly 4-bit arithmetic operations. Okay. Now I will show you very simple way. Just I didn't design, but I have to show you how it is designed. Okay. First of all, 4 multiplexer will consider to receive the data from B only. I told that is because here is the equation D is equal to A plus Y plus Cn. So A data directly we can use, and B data receive from that is a multiplexers. So B data receive from multiplexers. So here you see, first of all we will see that is multiplexers data, how it is received. 2 data we will provide. One is one thing, since 4 multiplexers are there, so 2 selectors first of all we will design. Okay, 2 selectors. Here we design 2 selectors, that is S0, S1, 2 selectors. We go through all selectors. Okay, very simple way, because which data that is activated or not, we don't know. Okay, so we can use 4 selector. Down is S0, S1. Similarly, here is S0, sorry, S0 and S1. Okay, here is this one S0. This is S1, actually it is not there. Here is similarly, here is S0, S1, S0, S1. Okay, 4 selector, because 4 selectors need to operate. And one part why I will make it you can also understand. One part I told that each multiplier receive the data from that is b0. So you can write here, suppose b0, b1, b2, b3, b4, whatever the number of that is bits of individual data. Okay, one from b, you see direct data suppose come to here, we can write 0, you can write 0. If it is a complement, if we go through some complement data, okay, we go through 1. Okay, similarly if we direct b data, here is b data, that means you can write it b0. Okay, if we go through b data, then what happens, we go through in this way. Similarly b1, b2, if we go through this one, and it is b2. Similarly here also I will show you, here also b3, here b3, okay, that means b0, here you see b0, b1, b2, b3 we can consider here. Another two data, one is logic data, also we can use logic data, very simple way, 0 and 1. Okay, 0 and 1 also we can use. If we go through 0, then it is used for that is 1 here, because two selectors are there here, 1 2 3, here 1 2 3, sorry 0 0 1 2 3, here 0 1 2 3, 0 1, okay, 2 3 2 3. Okay, if we go through this particular data, very simple, 0 1 2 data we come from here. Okay, 0 data, sorry 0 1 2 data, number 2 position data we can go through this logic. Okay, very simple way we can go through this one. If it is negative data, 0 negative means here is 1. Okay, if we go through 1, then what happens, we go through 3 data. So 3 data is there, we just draw in this way 3 data. Okay, we just connect to 3 data here, very simple way. Okay, so this is the basic concept of this b data and 0 data. So how many, that is 4 digits are there, position 0 1 2 3, 0 1 2 3, 0 1 consider either 0 is considered b0, b data directly, b complement data 1. Next logic data, 2 data is logic data 0 data, if 3 that is 1 data, you see that is 1 data, very simple way it is mentioned, it is 1 because it is a 0 direct, if you 1 in this way. And another is a carry out data. Okay, this is the basic concept. Another is a carry out data. Carry means CN also we can use here, carry in data. It has a 2 part, you see it has a 2 part, C0, another part also here available, we can also see B, here is a A0 data, also we can put A0 data here, 2 data is there. Similarly here is a A1 data, A1 data direct put here. Okay, another data from multiplication data, B data or 0 1 data we will consider here, but A0 direct connect. Okay, so here x0, you see x0 y0. Okay, similarly here is a here is x1, if we go through this one, y1. Okay, so here also we go through, that is a x2, sorry here is b2, a2 come through here, b, it is a y2. Similarly here a3 we come to here, and here is it is x3 y3. Okay, like this data is considered in this way, very simple way. Next is its output. We can also here C0, whenever again carry out to C1, again carry out to C2, again carry out to C3. Okay, like this we can carry out different data. So whenever output we can get, then what data we get output? It is a D0, it is a D1, okay, it is a D2, it is a D3. Okay, these different data we can get it. This is the total design of a logic circuit. We will discuss one after one. This logic circuit, how it is useful. Okay, how it is useful, I will tell you. Okay. Okay. So you see, this is that is a design of a 4-bit arithmetic circuit. But the main part is it is use the 4 multiplexers and 4 full adder. Since it is a 4-bit arithmetic circuit, so 4 full adder you will consider, and that full adder receive direct A data from directly to X, and Y data collect from multiplexers. Multiplexer also collect the data, that is B data and B complement data. Similarly, one logic data also, you can see some logic data also 0 or 1. That logic data also we can consider. Okay, very simple way we can consider, that is logic data. So suppose any data, suppose D1, for example D1, we have to write that is A0 B0, for example, as per this rule. Y is suppose receive 0 means B0, okay, and X0 is A0, C0, okay. If the all are 1, C0 suppose 0, then what happens? X0 is A0, Y is B0. If it is 0, that is B0, A0 plus B0 plus C0. C0 means 0. Then what happens? We can consider in this way, that is D is equal to A0 plus B0 plus 0, that is A0 plus B0, that is D0. Okay, like this different data can be considered, can be designed, okay, according our requirement. So there is no problem whenever we calculate any kind of operations. Okay, that is very simple way. I will tell you how we will calculate this kind of operations. Now we will start that operations based on that equation. I have already told that equation is D is equal to A plus Y plus Cn. Absolutely it depend on this D equation. Now this equation, very simple way. For example, how to make that is subtract. Okay, D is equal to that is subtract part. Subtract part means, you see, very simple way I will show you. Suppose B subtract means what you write it, that is A minus B. Okay, subtract means A minus B. How to design? That is A plus minus B. Okay, that means what? A plus B complement plus 1. Okay, B complement plus 1. That means what are the value of B? That is B complement. It should be B complement. You have already maintained the B complement here. Suppose B0 complement means here. Okay. Another part is 1. 1 is where? It is a part of Y. And this part is Cn. That means Cn is 1, Y is B complement, and A part is there. Then it will define D. So here D, very simply it is mentioned, one part is A part is directly X0, no problem. B part is a B complement, if we go through B complement only, then Y0 is a B complement, here is a B complement, Y part is a B complement. Then C in this part is 1, then what happens? B complement plus 1, okay. B complement plus 1 means minus B. So automatically D is equal to A minus B. So automatically D0, here if you define D0 is equal to A0 minus B0. Like this we can define. Okay. Different ways we can also define. What are the values of that? How to define? Different ways we can define. Now we will see how different values can be done from this 4-bit arithmetic circuit. How to define? Okay, that we will see. Now we see very simple way. If we go through function table, arithmetic circuit function table, then we can find out what are the that is functions can be done by this particular circuit. That is the most important part. Main motto is how different operations can be done by this common particular standard this equation as well as this particular logic circuit, means arithmetic circuit. How will you define different operation, a plus b, a minus b, a plus b increment, or a increment, a decrement, okay, or a data transfer directly, how, okay, that kind of things we will see. Sometimes b is 0, sometimes we will see that at what situation. Now see, you will see that is arithmetic. I have to write very simple way. We will write that part. That is a arithmetic or arithmetic, okay, circuit functional or functional table, okay, circuit functional table. Before this we just understand or we remember this part, that is d is equal to a plus y plus cn, where cn is that is b data and logic data, okay, logic 0 and 1, that is received for y. This is the concept, okay. Now we see or we draw this functional table. How to define that functional table? Very simple way, I will draw that. Okay, so now we will see what kind of arithmetic circuit with a certain functional table, and the main part is output of d is equal to a plus y plus cn. Y is dependent on b and some logic, and cn is already there, we will put it. Another is a micro operation, okay. Another is what kind of micro operation we can use, okay. So now we see whenever I go through different operations, so then we see what kind of value we can consider. Very simple way, we can see these values. S0, very simple way to take, because it is considered as different part. Here you see if Cn is 0, okay, then what happens? If it is 1, then what happens? Having same value we can consider, since it is a Cn value is 2 values, okay. Similarly 1 1, it is 0 1, it is 0 1, it is 0 1, it is 1 0 1 0, it is 0 1, it is 1 1 1 1. Why it is this type of things we consider? Because they absolutely depend on Cn. Cn is 0 1 means same value we can consider 0 0 for 0 0 0 is 1. If we again 0 0 0 1 0 1 like this. So in this way, how many? That is 8 number of cases can be considered, since 3 inputs S0 S0 S1 Cn, okay, like this. Now we will see what is the y value. Very simple way, we will consider what is the y value. Y value, you see, if we go through this one, how to define y value? Y value depend on this because y is depend on what is the concept of y. You see, y is defined here. Very simple way it is mentioned. Y is depend on b or b complement or 0 or 1 complement. Okay, b 0, b first is b 0, b complement is 1. Here I will share you. B position is 0, b complement is 1, 0 complement 2, 1 complement 1 is logic 1 is 3. This is the basic concept. If b, you see, b means it is a 0 position is b, that is y. Okay. Now we see 0, how to define? 0 is defined through two selectors. Okay, selection variable. 0 defined S0 S1. If it is defined 0, then B0 is coming. If it is 1, B complement is coming, S0 S1. If S0 S1 2 defined, that is 2 is 0, we will get it. If S0 S1 defined 3, then 1 is, we can get it. Based on that, y value may be b complement, maybe 0, maybe 1, like this. Okay. we can define in this manner. Now we will start what is the different concept whenever go through that equation. If is 0 0 0 0 means a b value, okay. If is 0 0 is b value, c in is 0, okay. So obviously y value, y very simple way, that is b value we can get it, okay. Similarly 0 0 means b value, very simple way we will see. 0 1 0 1 is 1, 1 means b complement, very simple way, because we have already discussed 1 means what, b complement, okay. Now 1 means here 0 1 means b complement, again 0 1 means b complement, again 1 0 1 0 means 2, here 2, here 2, that is 0, you see 2 means here 0 value, you see is 0 value means 2, 1 value means 3. So you see that is a 0 value, we can 0 here, that is a, since it is 2 position of value, here 1 means 1 1, you see 1 1, okay. So y value completed. Now we put all value, a value, b value, or y a value, y value, c n value. Now evaluate, very simple. Now d is equal to, you see a is there, no problem. A is always consider, because you see whenever I go through this output through some full adder receive direct a value, you see direct receive value, no problem. A value direct receive, a value direct receive, doesn't matter. Only y, since y depend on b value or logic value, then y value will be vary based on that which position of the S0 S1, okay. Y value will vary, but a value is fixed, you see every time a value is fixed. So you see whenever I go through this one, here a is there, y is b, obviously b, c is 0, so obviously it is 0, so no problem. D is equal to a plus b, very simple way, d is equal to a plus b. So what is the value, or what kind of that micro operation you use, that is r, okay, because since it is a plus b, we can create that is r. In this way different functional table we can create, different values we can find out for this particular this equation, d is equal to a plus y plus cn. How to define, I also define. So again you see, next d is equal to a is compulsory, and b is what, b value is you see here is y is b, so no problem, here b, okay, and plus 1, because cn 1, cn is 1, so plus 1, okay, like this. Now see, this is the first is over, this is a micro operation. So next is what happens, d is equal to a plus b plus 1. Here what happens, you see it is very simple, addition a plus b we have already know, again just carry out which 1, okay. So simple we can write add with carry, because carry 1 is there, add with carry, that kind of things we can also use, okay. Now we see here, very simple way. Next d is equal to a plus, here b complement, because here mention b complement, and cn is 0, no need, right, okay. Then if that is b complement, simple b complement is there, then what you write, that is a subtract, you can write a subtract with borrow, okay, subtract with borrow. In this way we can define, very simply. If it not plus 1 or something, with borrow, just subtract with borrow, so something borrow from previous data, okay. And if we go through this one, very simple, a plus b complement already there, cn is 1 plus 1, so obviously we see this value b complement plus 1 means minus b means a minus b, you can write this one is minus b, okay. Since this one is minus b, that is a minus b, in this way. So what you write, very simple, that is a subtract, okay, we can write a subtract, this is the subtract operation we can consider, okay. Here you see b data is considered, because 0 0 0 1 0 0 0 0 0 1 for B data. After that, no B data. You see, very simple way. You see that second 1 0 2 and 1 1 is 3 position. So second position or 3 position is 0 data. 0 is second position, means 2, and 1 is third. Okay, this data is 0 or 1. At that time, B data not considered. Okay, since B data not considered, then what data we will consider? Very simple way. D is equal to, now we will calculate same thing. A is compulsory, B is not there. Instead of B, that is what, Y is 0. You see, Y is 0. Okay, C is also 0. Both are 0. So what you write? D is equal to A. If D is equal to A, then what happens? Simple transfer. Okay, transfer data A. Simple A data transfer to D, direct data. So there is no B, so direct transfer data. Again, here we see A is compulsory plus, that is Y is 0. Y is 0, no problem. Here is 1. Okay, A plus 1, because C is Y is 0, Y part is 0, C is 1, C is 1, A plus 1. A plus 1 means what you write? That is a increment. Okay, that is a increment. We can write increment of A. Increment of A. Okay, next D is equal to, here you see, since 1 1, very simply I will tell you, since it is 1 1, 1 1 is actually, whenever logical data is 1 1, it is actually, it is a minus 1. Okay, 1 1 is a minus 1. I will show you how 1 1 is a minus 1. Very simple way, I will tell you how 1 1 equivalent to minus 1. How? You see, 1, that is negation of negative of 1. 1 value is 0 1. Okay, whenever 1, how to make a minus 1? Minus 1 is 2's complement to 1. 2's complement to 1 means here we are writing are 2's complement. Oh, sorry, 2's complement to 1. 2's complement of 1. 2's complement of 1 means 1's complement plus 1. So if 1 is defined, first we will consider 1. 1 is 0 1. 1's complement is 1 0. Okay, 1 0 1 0 is 1's complement. We can write 1's complement. Okay, 1's complement. After that 1 is added, because 1's complement plus 1 is 2's complement. 1 is added, that is 1 1. That means this 1 1 is the what? Minus 1. 2's complement, this is 2's complement. So 2's complement means minus. Okay, minus of what? Minus of 1. So it is a minus 1. Okay, in this way we can find that is the what the value of that. If 1 1, logical data is 1 1, then we can consider minus 1. Okay, so now we see, here is data, very simple way we consider this Y is 1, very simple way. You see, Y is 1, and this 1, in this case we consider the third position. You see, very simple, we consider is a third position. 1 1 means third position. Third position is 1. So you can write here, very simple way, whenever you go through that 1. 1 means, I show you, this 1 means this position 1 1. That 1 means that is a minus 1. Okay, this 1 means minus 1. Minus 1 means what you write? This 1 means minus 1. 1 is created through this one. This one means minus 1. So we can write A minus 1, not directly like A plus 1. Okay, A minus 1, because Y value is 1 means minus 1, and here 0 means sin is 0. After that sin is 0. A minus 1 plus 0. Okay, that is A minus 1. So in this case what happens? We can write decrement of A. Okay, we can write decrement of A. Okay, next, here what happens? A Y value is 1, here 1 is minus 1, here also minus 1. That means A minus 1, sin is 1. Okay, sin is 1. That is, what is the value? That is A. Okay, that is A. That is means a transfer. A means direct transfer of A. Okay, that is a transfer of A. So now we see the number of different arithmetic operation can be considered, and also this corresponding functional table also we can define in this way. You see one observation we can see. You observe one thing. In this case, what happens? To transfer data A, we can find or you can define through this equation. D is equal to A plus Y plus C. So in this case, what happens? Since it has a number of cases, 1, 2, 3, 4, 5, 6, 7, 8. 8 cases we can consider for arithmetic operation. But since we both are same, it here transfer A, here it transfer A. So total 7 condition or 7 cases we will consider for different arithmetic operations. Okay. So in this way we can define different kind of that is values of S0, S1, Cin, Y, and whenever evaluated those all data for this D is equal to A plus Y plus Cn, then automatically what kind of micro operation we can get, then we will see that. In this way we can evaluate D value. Okay, this is the basic concept, basic fundamental concept how to define the arithmetic operations through the standard equation D is equal to A plus Y plus Cn. Okay, so I think all of you understand this part. I hope you understand all things. Thank you very much to watch my this videos. Okay, it's a very simple way I define all part, that is design 4-bit arithmetic circuit and its corresponding functional table. Okay, this is a very simple that is a arithmetic circuit design, but keep mind how to define, how to design those part. Okay, thanks to all to watch my videos.